kind of weird, right? Because we're used to a circle having a center. It's that point right in the middle of the circle where all the other points are the same distance from that center. But it turns out that triangles also have centers, but they're created in different ways. So let's look at the first type of center. It's called the circumcenter. Okay, it's called the circumcenter. It is created by, does anybody know what these segments, MX, MY, and MZ, does anybody know what those segments right there are? It does have to do with the midpoint of each side. This notation right here, these tick marks mean that AX is the same length as XB, BY is the same as YC, so forth and so on. Okay, so midpoint of the sides. What else do we see going on with the diagram?
They're right angles.
They're all right angles. Okay, so if we put those two things together, right angles are perpendicular. And if we have midpoints, that means something has been cut in half. And what does that is a bisector. Okay, not perpendiculars. Perpendiculars, not plural. Perpendicular bisectors. There we go. Put the plural in the wrong word. Circumcenter is created by the perpendicular bisectors. XM, MY, and MZ are the perpendicular bisectors. They are perpendicular to the side, and they cut each side in half. The circumcenter, there are other segments here on our picture. Let me highlight these. Okay, XM, MY, and MZ are the perpendicular bisectors. They intersect right there at M. M is the circumcenter. Okay, M is the circumcenter, that point right there. The circumcenter is equidistant. Anybody know what equidistant means? Equal distance. Okay, just break down the word. Equa is equal, distant, meaning distance. So it's the same distance from each vertex of the triangle. Okay, it's equidistant from each vertex of the triangle. So that means the distance from A to M, the distance from C to M, and the distance from B to M are all the same length. Okay, AM equals BM, which equals CM. So we could mark those as well. Let's see here, we've already used up to 3 tick marks, so let's use 4 to mark that those are congruent to each other. AM, BM, and CM are all equal to each other. Okay, the circumcenter is equidistant from the vertices. Okay, let's look at what we've got for the next one, the incenter. Okay, the incenter. This time, we're going to focus on AM, BM, and CM. Does anybody know what those may be? What's going on with AM, BM, and CM? What different? They cut the angles in half. See this different notation right here? This is indicating that A has been cut in half, B has been cut in half, C has been cut in half. Those are called angle bisectors. Okay, these are angle bisectors. So where the angle bisectors all intersect, they're in the middle. M, in this case, is what we call the incenter. Now notice it's the same triangle, but M is in a slightly different place. Okay, slightly different than the previous one, but it's pretty close to the same place. So the incenter is equidistant from each side. Okay, the incenter is equidistant from each side. So XM, YM, ZM. Those are the measurements. To measure from a point inside of a triangle to the side, you measure perpendicular distance. So we can mark these. Oh, I didn't have to put that many marks, did I? I was thinking about the last one. There we go. Let's just put one. It doesn't matter how many you put on there. I was just realizing I didn't have to put 4. Okay, so XM is equal to YM, which is equal to ZM. All right, so circumcenter created by the perpendicular bisectors, equidistant from the vertices. In-center angle bisectors, equidistant from the sides. The last one we're going to talk about is what we call the centroid. Okay, the centroid is created by the medians. Okay, it's created by the medians. So we've got that property back where it's halfway. It's cutting the sides in half there, but this time it extends all the way from a vertex. So a median is created by a vertex connected to the midpoint of the opposite side. Okay, a median is created by a vertex connected to the midpoint of the opposite side. So if we start at A, start at that vertex, Y is the midpoint on the other side. So we're connecting that right there. If we start at B, Z is the midpoint of the opposite side. So that's a median right there. And then if we start at C, X is the midpoint on the other side. So the centroid here is M. All of these have been in the same general area. There's just a slight difference in their position. But for the most part, these centers have all been the same. Now, if we ended up with a triangle that was a little less even, I guess you would say, this triangle, it's not an equilateral triangle, but it's pretty close to an equilateral triangle. So that's why these centers are all in a similar location. If we had a triangle that was a little more skewed one way or another, the centers would be in different places, definitely. Okay. Now, what's going on here is M is not equidistant from the vertices or the sides, but what happens is, see how all of these medians are kind of cut into 2 pieces? The longer piece is 2 times the length of the smaller piece. So BM there is 2 times the length of MZ. We can say the same thing about CM. It's 2 times the length of MX. And AM would be 2 times the length of MY. Okay, so that's the property that's going on here. Now, to be honest, when I read the standard, let me read the standard to you exactly so you know what the state of North Carolina says. The state of North Carolina says, where did it go? Oh, there it is. Verify experimentally properties of the centers of triangles: centroid, in-center, and circumcenter. So it doesn't even say apply the properties or prove anything. Apply is one of their favorite words. That's when you would really have to take these properties and use them. It just says verify experimentally. So the way that I've been taught to interpret that is you just need to be able to look at a diagram and recognize which one we're talking about. So let me give you some tips on keeping these separate. Circumcenter is the longest name for the centers of triangles. Okay, circumcenter is the longest name. So is what it's created by, perpendicular bisectors. Okay, circumcenter, perpendicular bisectors. Those are the longest names. In-center is the only one that starts with a vowel. Okay, it starts with an I. It's the only one that starts with an I that is created by. angle bisectors. So in-center, angle bisector, the vowels go together. And then centroid is the shortest name. Well, it's probably the same length as in-center, but it has the shortest name that it's created by. It's created by the medians, okay? So longest name, circumcenter, longest name, perpendicular bisectors. Vowel, in-center, vowel, angle bisector, and then centroid is medians. That's the best way that I can remember to keep them apart from each other. Okay. And then from there, it's just understanding the markings to recognize what's a bisector, what's a perpendicular bisector, what's an angle bisector. Okay. So that's centers of triangles. Since it doesn't say apply, I don't see a point in spending a lot of time trying to do some problems using the properties and things like that. So I'm pretty much just giving this information and hoping that you will memorize it and be able to recognize the diagram if you're given one. Okay.